Good morning all. Today we will start a new topic, that is filtering in the frequency domain. In this topic, filtering in the frequency domain, we will first discuss about the Fourier series. So Fourier series, it is a mathematical tool and it is used to represent periodic signal as a function of sine and cosine terms. So this is the general expression of Fourier series. It consists of three terms, one DC term, a cosine term and a sine term, and the various coefficients and the equation for various coefficients a naught, an and bn, it is given here. So we will solve a numerical question based on Fourier series. So in this question, a periodic waveform it is given to us, and for this periodic waveform we will perform the Fourier series expansion. So for this given waveform, first we will compute its time period. So for this given waveform, since this waveform is repeated after an interval of 2 pi, so the time period t for this given input waveform, it is 2 pi. Now we will write the general equation of Fourier series. The general equation of Fourier series, it is f of x, it is equals to a naught plus summation n is equals to 1 to infinity an cos 2 pi nx by t plus bn sine 2 pi nx by t. Now in this equation we will substitute the time period t is equals to 2 pi. So the equation is reduces to a naught plus summation n is equals to 1 to infinity, it is an cos 2 pi nx by 2 pi. In place of t we will substitute the value 2 pi plus bn sine 2 pi nx by 2 pi. On further simplification, f of x, it is reduces to a naught plus summation n is equals to 1 to infinity an cos nx plus bn sine nx. So for this given waveform, we have obtained our Fourier series expression. Now in this expression, we have to determine this coefficient a naught, an and bn. For the same, we will define the given f of x. So the given f of x in this waveform, this f of x is equals to 1 when the x varies from 0 to pi. So f of x is equals to 1 when x varies from 0 to pi, and f of x equals to minus 1 when x varies from pi to 2 pi. So f of x is equals to minus 1 when x varies from pi to 2 pi. And earlier we have determined the time period t of this given waveform, it is equals to 2 pi. So our next step, we have to determine this coefficient a0, an and bn. Next we will determine this a0 coefficient. The general expression of a0 coefficient, it is 1 by t integration 0 to t f of x dx. So we have already determined the time period is equals to 2 pi. So substituting t is equals to 2 pi in this expression, it becomes 1 by 2 pi integration 0 to 2 pi f of x into dx. F of x, it is split into two parts. When x varies from 0 to pi, f of x is equals to 1, and when x varies from pi to 2 pi, f of x is equals to minus 1. So we have to split this integration also. 1 by 2 pi integration from 0 to pi, f of x is equals to 1, so it is 1 into dx, plus integration from pi to 2 pi, and in pi to 2 pi, f of x is equals to minus 1 into dx. Now we will perform the integration. 1 by 2 pi integration of dx, it becomes equals to x, and the limit is varies from 0 to pi. Next, this minus we will taken it out. Integration of dx, it becomes x, and here the integration, here the limit varies from pi to 2 pi. Now we will substitute the limits. X varies from 0 to pi. So first we will substitute the upper limit, that is pi. Then we will substitute the lower limit, that is pi minus 0. Next, here also we will substitute the limit. So it becomes 2 pi minus pi. On further simplification, it becomes 1 by 2 pi multiplication with pi minus pi, that is equals to 0. So we have determined our first coefficient a0, it is equals to 0. Next we will determine the next coefficient, that is an. The mathematical expression of an, it is 2 by t integration 0 to t f of x cos 2 pi nx by t into dx. We will apply the same procedure. First we will substitute the value of t, that is the value of time period, which is equals to 2 pi in this question. So we will substitute here t is equals to 2 pi, so it becomes t 2 by 2 pi integration 0 to 2 pi f of x cos 2 pi nx by 2 pi into dx. So on simplification, we will obtain the expression 1 by pi integration 0 to 2 pi f of x cos nx dx. Now we will split this integration from 0 to pi and pi to 2 pi. So in this question, 0 to pi fx is equals to 1 and pi to 2 pi fx is equals to minus 1. So we will split this integration into two parts. 1 by pi integration 0 to pi fx is 1, so 1 into cos nx dx, plus from pi to 2 pi fx is minus 1 into cos nx dx. Now we will perform the integration. 1 by pi integration of cos nx dx, it is sine nx by n. So it is sine nx by n. The limit varies from 0 to pi. This minus we will taken it out. Then we will perform the integration. Cos nx dx integration is sine nx by n. And the limit varies from pi to 2 pi. Since this n is a constant, so we will take this 1 by n coefficient outside. So it is 1 by n pi. Now we will substitute the limit from 0 to pi. So it becomes sine n pi minus 0. Sorry, sine n pi minus sine 0. Minus, here we will substitute the limit pi to 2 pi. So the expression becomes sine 2n pi minus sine n pi. And in our trigonometry, we know sine 0 is equals to 0 as well as sine n pi is also equals to 0. So this entire expression, it is evaluated to be equal to 0. So we have determined our next coefficient, that is a of n, and we obtained a of n is also equals to 0. Next we will determine our next coefficient, that is b of n. The mathematical expression of b of n, it is 2 by t integration 0 to t f of x sine 2 pi nx by t into dx. We will apply the same procedure. First we will substitute the value t equals to 2 pi. So the expression becomes 2 by 2 pi integration 0 to 2 pi f of x sine 2 pi nx by 2 pi into dx. So which on simplification, it is reduces to 1 by pi integration 0 to 2 pi f of x sine nx dx. Now we will split this integration from 0 to pi and from pi to 2 pi. So the expression becomes 1 by pi integration 0 to pi. For 0 to pi, f of x is equals to 1. So here I will write 1 into sine nx dx plus integration from pi to 2 pi. For pi to 2 pi, f of x is equals to minus 1. So I will write here minus 1 into sine nx into dx. Okay. So it is 1 by pi integration of sine nx dx is minus cos nx by n, and the limit varies from 0 to pi. This minus we will taken it out, and integration of sine nx dx, it becomes minus cos nx by n, and the limit varies from pi to 2 pi. Next we will substitute the limits. So let me rewrite this expression here. 1 by pi minus cos nx by n 0 to pi minus of cos nx by n. The limit varies from pi to 2 pi. This coefficient 1 by n, we will taken it out, so the expression becomes 1 by n pi now we will apply the limit from 0 to pi, so it becomes minus cos n pi plus cos 0 minus of, we will apply the limit pi to 2 pi, so it becomes minus of cos 2n pi plus cos n pi. We will simplify this expression. Cos 0 is equals to 1 and cos 2n pi is also equals to 1. So if we substitute the values, it becomes 1 minus cos n pi minus, we will taken it inside, it becomes cos 2n pi is equals to 1. So if you taken this minus inside, it becomes plus 1 minus cos n pi. So we have obtained the expression of Bn, that is equals to 2 by n pi multiplied with 1 minus cos n pi. So our final expression of Bn, it is equals to 2 by n pi 1 minus cos n pi. So this is our earlier Fourier series equation, and in this equation we have to determine this value an, a0, an and bn. So we have obtained a0 is equals to 0, we have obtained an is equals to 0, and we have obtained the expression for b of n, it is equals to 2 by n pi 1 minus cos n pi. So the expression of a0, an and bn we will substitute in our Fourier series equation. Our Fourier series equation was f of x is equals to a0 summation n is equals to 1 to infinity a of n cos nx plus b of n sine nx. Now we will substitute the value of a0, an and bn. So we have obtained a0 is equals to 0 and an is also equals to 0. So only one expression we will have, that is n is equals to 1 to infinity b of n sine nx. On substitution, the expression for b of n, we will get the expression 2 by n pi 1 minus cos n pi into sine nx. Now let me open this expression for few number of terms. First, for n is equals to 1. For n is equals to 1, here I will substitute 1. Here I will substitute 1. Here also I will substitute 1. So the expression becomes 2 by pi 1 minus cos pi into sine x. Next we will write for n is equals to 2. For n is equals to 2, it becomes 2 by 2 pi 1 minus cos 2 pi into sine 2x, plus for n is equals to 3, it is 2 by 3 pi 1 minus cos 3 pi sine 3x. For n is equals to 4, it is 2 by 4 pi 1 minus cos 4 pi into sine 4x. One more term we will write, that is n is equals to 5. So the expression becomes 2 by 5 pi 1 minus cos 5 pi into sine 5x, and so on up to infinite number of terms. Now look at this. First term 2 by pi, cos pi is minus 1, minus of cos pi it becomes 1. So 1 plus 1 it becomes 2 multiplied with sine x. Next term cos 2 pi is 1, 1 minus 1 it is evaluated to be 0. So this term, if it is evaluated to be 1, 1 minus 1 it becomes 0. So this expression is 0. Next cos 3 pi is minus 1, minus of cos 3 pi it is plus 1, 1 plus 1 is 2. So the expression becomes 2 by 3 pi multiplied with 2 into sine 3x plus cos 4 pi. Cos 4 pi is 1, 1 minus 1 it is evaluated to be 0. So this entire terms becomes 0. And last cos 5 pi is minus 1, minus of cos 5 pi becomes plus 1, 1 plus 1 it becomes 2. So the expression becomes 2 by 5 pi multiplied with 2 multiplied with sine 5x. So on simplification, on further simplification, this expression is reduces to 4 by pi into sine x plus 4 by 3 pi into sine 3x plus 4 by 5 pi into sine 5x up to infinite number of terms. So 4 by pi, if we take it common, this is sine x plus 1 by 3 sine 3x plus 1 by 5 sine 5x, and up to infinite number of terms. So for the given question, so for this given waveform, we have obtained our Fourier series expansion, and this is our final result. Thank you.